Hey guys, Arjun here. Today's video is going to be about breadboard components, so let's get right into it. Alright, I'm going to go over some simple breadboard components. And the first one I'm going to show you guys is the LED. And on the LED, you can see that there are two main parts. You have the metal legs here, and you also have the place where the light is coming out. And LEDs come in many different colors. I have red, green, blue, and many more. There's also RGB LEDs. And when you first take a look at the LED, you'll see that the legs, there are two of them, one is actually longer than the other. And there is a reason for this. The longer one is called the anode, and the shorter one is called the cathode. The anode is where the current is going to be entering the LED, and the cathode is where the current is going to be leaving the LED. Now, this is important for when you're building your breadboard circuits, because if you switch up how you're placing your LED on the breadboard, it will not turn the LED on and result in problems. Alright, so this is pretty much what an LED looks like when it's turned on. And one thing you can notice is that I have another part here that I have not told you guys what it is. And this is called a resistor. Let me show you what this is. Alright, you can see here that this is a resistor up close. And just like the LED, it has two legs. And a question a beginner may have is, what is a resistor? Well, just like the name suggests, a resistor is a device that restricts the flow of current. And why is this important? Well, let's take my LED here, for example. My LED can only support a certain amount of current, which means I can't just bombard it with a huge amount of current, because if I do that, then it'll just blow up. So we need something that can lower the amount of current that the LED is going to receive. And that is what the resistor is going to do. It'll restrict the flow of current so that my LED doesn't blow up, pretty much. And you can see here that on my resistor, there are different colors here. There's red, brown, and a golden line. And all these lines show is the rating of the resistor. You can see here that now I have a different type of resistor, brown, black, orange, and gold. And this just shows that it's a different rating than the one that I have over here. By the way, what is the unit of resistance called? It is called ohms. So most of the resistors that I'm going to be working with are 220 ohms of resistance. And what is the range of resistance? Well, resistance can range anywhere from 0 ohms, they say 0 ohms, but it's just very little resistance, all the way to, I think the highest is 10 petaohms, which is a total of 16 zeros. Alright, so the next component is called a button. A button looks like this, and it has a total of 4 pins. And from the top, you can see that you can push this down. So a button is basically a switch that opens and closes the circuits and can stop the flow of current or keep it going. So let me show you how this looks on a breadboard. Alright, so here I just set up a simple circuit, and let me show you what a button actually does when it's connected to a circuit. So here I just have an LED and a resistor, and now when you can see that when I press this button, the LED actually turns on. So this is because the switch is closing the circuit, which allows current to run through the circuit, and therefore turns on the LED when I press it down. Alright, so the final component I want to talk about are jumper wires, which look like this. And you probably have seen me use these before. I have connected them to my Raspberry Pi, and jumper wires basically are used to transport power or just move the current from one place to another. So let's say I have power that is coming from my Raspberry Pi. How do I get that power to be supplied to my breadboard? Well, that's where a jumper wire comes in. I can connect my jumper wire to my Raspberry Pi and then just push that into my breadboard, and now I have power supplied to my breadboard. There are three different types of jumper cables: male to male, male to female, and female to female. The first two, male to male and male to female, are the most common ones used. Male to male looks like this. Both of the ends of the cable have pins, so this allows you to transport power on the actual breadboard. Male to female looks like this. One end has a pin and the other one doesn't. Male to female are probably the most common ones that I use. These are the ones that I use to get power from my Raspberry Pi and then connect that to my breadboard. And finally, there are female to female cables. And I don't use these ones much. They're not really needed, and they're kind of useless. Anyways, you can see here that I just built another simple circuit, and I have two male to female wires. One of them, the red one, is my wire that is supplying power to my actual circuit, and this is connected to one of the Raspberry Pi pins. The second one, the yellow wire, is the ground, and this is also a male to female wire. Now let's say I was going to add a bunch of other elements to my breadboard, to my circuit. Well, that means I would need a lot more space than just in this congested area over here. This is where my male-to-male wire is going to come into play. So I'm just going to take out my ground over here, and now I'm going to take out the LED, and now I'm just going to plug this male wire, one of the ends, into here. And I want to plug the other end somewhere, let's say on the other side of my breadboard, so that I can have a more open area. And finally, I'm just going to put my LED back in, and then I'm just going to connect my ground. And so you can see that now the whole circuit is stretched across the entirety of the breadboard, and this is pretty much what male-to-male wires are for. You can use them to transport power from an existing place of power to another, and male-to-female wires are used for getting current from a power supplier. Alright guys, that's going to be it for today's video. Hope you enjoyed, and I'll see you in the next one.